you are doing great. If I am clearly visible and audible, please let me know in the chat box. Okay? So I know you guys are waiting for a while from very start of the time. So you can just put in the chat box whether I am clearly visible and audible to all of you or not. Okay. So I can see the chat box. I'll just see whether my voice is clearly coming and whether I'm visible to you all or not. So I can see that a lot of you are commenting in the chat box, and yes, okay, so I am clearly audible to you and visible to you. So again, a very good evening to all of you. Myself, me Panchal, and I will be your host for this part two of webinar series by Nawaz Edutech. Those who have attended our part one of this webinar series, I welcome all of you again for this part two, that is the second lecture of the series. Those who have joined us for the first time during this series, for your information, Nawaz Edutech is celebrating World Space Week, which is an annual celebration that takes place from 4th of October to 10th of October. It is celebrated in over 95 countries worldwide. It serves as an international recognition of the contributions of science and technology to the betterment of humanity. Now, to kick off our gathering, let's start with an interesting, fun question. Okay, the same similar type of question that we asked in the last part also. So today's question is: suppose you won a lottery and you are getting a chance to visit any celestial body in the solar system. So, which planet or moon or any celestial body in the solar system will you select for your visit? Okay, so you can put down that your answer in the chat box. So again, I'll repeat my question. Suppose you won a lottery and you are getting a chance to visit any celestial body in the solar system. So which planet or moon will you select for your visit? Okay, so you can select any planet, right? There are many planets in our solar system. There are many moons in our solar system. So you can let me know in the chat box so that I can also see where you are. Okay, okay. So I'm getting answers. Some of you are interested to go to the Mars, and some of you are planning to go to galaxy. Okay, okay, that's nice. Yeah, most of you are interested in going Mars, Titan, and all that. Okay, that's great. That's great. Okay, we got the wonderful answers. Some of you are planning to go to Saturn also. So just keep this energy with you to boost up this energy. We are privileged to have Professor Siddharth Kasthurirangan with us today during the World Space Week. Sir is currently an assistant professor in the Department of Physics, University of Mumbai. His primary research work is in the field of accelerator-based atomic physics. His current research interests include atomic physics and atomic astrophysics. He has several research publications in reputed international journals and has contributed to several international and national conferences. I personally feel fortunate that I got an opportunity to do research under Sir's guidance. He has delivered a number of talks of both technical and popular nature, including topics like physics, what and how, particle accelerators, engines of discovery, and nanotechnology. Today, as he speaks about our very own solar system, we can look forward to an engaging presentation that not only highlights interesting facts about the solar system, but also connects it with humanity's historical journey through science. And at the end of the lecture, I would like to request Sir to share his experience and how one can join the field of astronomy and astrophysics. So please join me in welcoming Professor Siddharth Kasthurirangan. Sir, over to you.
Thank you, Meet. I hope I am audible clearly.
Yes, sir, you are clearly.
Okay. Let me share my screen so that we can start. So I hope this is the right one. Let me know when my screen becomes visible.
Yes, sir, your screen is visible.
All right, so let us start. Good evening, friends, and I'm very happy to be here with all of you today. It's always nice to share a few things which I got picked up along the way. And you are a very nice audience. I already saw all the responses to the initial question, where will you go if you win a lottery? And all these answers are there, that I want to go to the entire universe, I'll go to some galaxy. It's beautiful. So, very nice to have such an enthusiastic crowd. All right. So, I'm just trying to figure out how will I. That's one. All right. So today we'll have a very brief look because of our time which we have, the duration. We'll have a very brief look about our solar system. How did it originate? And a few fun facts about the sun and the planets and asteroids and the satellites of the planets, dwarf planets. We'll have a little fun. Let's see how it goes. I'll go a little quickly. If you didn't understand something, you can always ask questions and we'll get back to you about that. All right. So this is a toy picture of the solar system. You got the sun, and then the nearest planet to the sun is Mercury, then Venus. You know this sequence, right? Mercury, Venus, Earth, Mars. Then you have got the giant planets, Jupiter, Saturn, Uranus, and Neptune. And then there are some other planets which are called dwarf planets. Pluto used to be called a planet and now it's called a dwarf planet. We'll come to that, why that happened. And there are other planets like Pluto, which are all dwarf planets. There is Ceres, which is between Mars and Jupiter somewhere. Then you have Pluto, which is beyond Neptune. And then after that, you have a series of planets, Haumea, Makemake, Eris. There are a lot of others. So we'll have a look at all of those, hopefully, today. This is just to give you a comparison, how are the sizes. So this is Earth, as you know. This is the size of Mars in comparison with Earth. Venus is almost the same size as Earth, slightly smaller. And then this is Mercury, the closest planet to the Sun, which is the smallest planet which we have right now. If you try to zoom out from here, you will see that the planets which we just now saw are at the bottom here: Earth, Venus, Mars, and Mercury. And you have got much bigger planets in the solar system. That is Jupiter, the biggest one, Saturn with the rings, and then Uranus, which is here shown as a light blue color, and then Neptune. Uranus and Neptune are almost the same. Uranus is slightly bigger. But these planets are all made up mostly of gases. They don't have a solid surface. You can't go and stand on the planet. So those who answered, I want to go to Jupiter and I want to go to Neptune, it's a very nice thought, but you won't be able to stand there. You just sink because the whole thing is made of gas. If you zoom out a little further, you have this. This is the sun. So now you can see how small is the Earth in comparison with the sun. So actually you can fit, if you look at the size of the Earth, you can actually fit 108 Earths just inside the diameter of the sun. It's that much of a difference. Of course, Earth doesn't fit inside the sun because we are very, very far away. And the distances of these objects are also very, very vast. So virtually all of the region which you see is empty space. And these objects are all very, very far away from each other. They are not all crunched together like we showed in the first picture. All right. So let's have a look at all these guys one by one. First, you have got the sun. By the way, this is not a real picture of the sun, means not what you will get with the camera. This is an X-ray picture or ultraviolet picture. So they used ultraviolet and X-ray cameras to look at the sun. And unlike what many people like to believe, an X-ray picture of the sun doesn't mean that you are looking inside the sun. It's just that some parts of the sun emit X-rays instead of normal light, and those are the ones you are seeing. When you look at this picture, you can see there is a lot of uh, movement along the surface of the sun. That happens because the sun carries a very large magnetic field. And also, if you look inside the sun, now we have never looked inside the sun. These are all things which scientists have somehow tried to understand, and this is the understanding which we currently have. The innermost region is where hydrogen is being converted to helium. That is what makes the sun shine. And then the rest of the place is all the heat getting conducted gradually, either radiated or convected to the surface. The surface, as a result, is very, very hot. The inner core is extremely hot. It's like 1,000,000 degrees there. And by the time you come to the surface, it's like around 5 or 6,000 degrees Celsius. And apart from this, you can see that the outermost layers of the sun sometimes have these dark regions called sunspots, and there are these bright regions called solar flares. And there are sometimes some amount of material is thrown out because the surface is very violet. That's called a solar prominence. And there is a lot of streaming particles in all directions, which is called the solar wind. All these things are going on with the sun. But believe it or not, the sun is just an average star. It's a medium-sized star. There are much bigger stars out there, which are much larger than the sun, much brighter, and a lot of different things are going on inside those stars, which make them different. All right. Now, having had a look at the sun, how did it come about? How did it come into existence? Well, the belief currently is that a lot of gas and dust was present, and eventually all of it came together and gradually formed the sun. And the sun remained the way it is. It has remained that way for around 3 or 4 billion years. This arrow shows where we are now in the age of the sun, and it will continue to be like that. And then eventually, after another 4 billion years, the sun will eventually start to become slightly bigger, become unstable. It will become much bigger. It will cover up maybe Mercury, Venus, even Earth. It will be called a red giant star at that stage. We won't be around, but someone else in some other galaxy might spot this, or someone else within our galaxy, but somewhere else. And after the red giant stage, it will eventually shed off all the dust and gas, and it will turn into something called a white dwarf star. This is what is going to happen. The sun is like us, right now the sun is a young 30-year-old, like it's at the stage where a human being would be 30 years old. It's at that stage of its life. It's having a nice time now. But later on, it will become old, and it doesn't die. It turns into another type of star called a white dwarf star. This is just a picture of how it would have been when the sun was being formed. So you have this big cloud of gas. A lot of that gas comes together at the center. And if enough of the gas is compressed at the center, suddenly it will start undergoing what is called a fusion reaction. That is hydrogen getting converted to helium. That starts a glow, and then gradually more gas would have come in, and that would have formed the sun. And in fact, this part is not entirely conjecture. We have actually seen clouds of dust and gas in the universe. This is a picture taken by NASA, that is Hubble Space Telescope. And this is called the pillars of creation, because each of these tiny red dots which you see in this picture are actually newborn stars. And they actually were able to capture these pictures and show that as soon as this dust and gas gradually coalesces into a single body, it forms something called a protostar, which gradually develops into a full-fledged star. A protostar is like a baby star, if you want, and then a full-fledged star. All right. The other thing which we talked about is that the sun has a very strong magnetic field. This is an ultraviolet picture of the sun showing actually those magnetic field lines. The escaping material from the sun gets trapped back because of the magnetic field. Some of it escapes out. The ones which get trapped back are called magnetic loops. The ones which escape form what is called the solar wind. And actually, because the sun has a magnetic field, there is a certain region in space. This is a region which is showing much bigger than our solar system. You can see all the inner planets are scattered very close to the center. This big dot is Jupiter, Saturn, Uranus, Neptune. This is the orbit of Pluto, the outermost one. And much further than that is a place where the inner part of the solar system is protected from what is happening in the rest of the universe or rest of the galaxy. So our galaxy, the Milky Way, has a very strong magnetic wind blowing, and the magnetic field of the sun basically isolates us from that, because the magnetic field acts like a kind of shield. And the region outside the magnetic shield of the sun is called the heliosphere, and the edge of the heliosphere is called the heliopause. Beyond this is what we call outer space. That is really space where we don't know what is happening. Now we do know because the Voyager probe actually entered into this space. But once the Voyager crossed outside the heliospace, the magnetic field is much higher. So the sun is actually protecting us from all kind of debris which is floating around and coming to collide with us. Tiny debris, not rocks or something, but small particles like protons and so on. Very energetic ones. The sun protects us from those. Sun protects us from the so-called cosmic rays. And the magnetic field of the sun actually does that. Similarly, because the sun has a magnetic field and Earth also has a magnetic field, between the sun and Earth's magnetic field will form a similar region which is called a bow shock, which you can see here. So the solar wind actually flows out. Solar wind is basically the particles which are not fully trapped by the sun's magnetic field. And the Earth's magnetic field protects us. Just as the sun protects us from the rest of the galaxy, the Earth's magnetic field protects us from the sun. We look at all the planets and how their magnetic fields behave, and we learn a few things about those things. The points where the sun's and Earth's magnetic field meet, or where the solar wind actually penetrates into Earth's magnetic field, you get these beautiful formations in the sky, which are called aurora. In the north, which means aurora north, and aurora australis. So this is a taken by NASA, which is formed into a video, which shows the evolution of the southern aurora. This is Antarctica, by the way. Phenomena happens near the magnetic north pole of the Earth. Magnetic north pole is on the other side of the magnetic south pole of the
Hello, sir. So can you hear me? I guess there's some network issue from you.
I'm back. I hope.
Yeah, you are back. Again, I guess your video is stopped. If it is taking too much bandwidth, you can turn off your video. Okay, so guys, sir is having some network issue. He will join in a while. In the meantime, I have one question for you. So, can you all guess which is the largest moon in our solar system? You can put it in the chat box so that I can see.
Hello.
Yes, sir, I can hear you.
Yeah, I somehow there is something. I had some problem with my internet connection, but I hope it holds.
Yeah,
I have
now,
shared
now,
my screen back.
yes, now it is clear.
Okay, let's do that. I'm very sorry about that.
No problem, sir.
Yeah. So let's look at the planets now. We had a look at the sun. Hopefully this holds. Yeah. Okay. So we were talking about planets and now we are talking about Mercury. I have kept a lot of factoids about Mercury, but you will be able to see these anyway if you look at any Wikipedia or something. So let's talk about the planet Mercury. You can look at the surface of Mercury where it's completely covered with a lot of craters. And this is, by the way, an actual image made or a video made from actual images, which are captured by the messenger probe, which was sent to Mercury. And the reason it's covered with so many craters is because it's so close to the sun. So whenever any kind of debris flies towards the sun, Mercury is many times in the way and gets hit. And she is like a kind of poor bodyguard, but a kind of mouse bodyguard for an elephant, which is the sun. So he just gets hit all the time. Mercury is a very weird planet because 1 or 2 days on Mercury is equal to 3 years on Mercury. It's very weird. And this 2:3 ratio is because the sun actually has Mercury tied up in a kind of tidal lock. So Mercury can only turn a certain amount while rotating around the sun. So it's very interesting, and this leads to some very interesting phenomena that when the sun rises in Mercury, sometimes it goes back. And if you are standing at the right point on the planet Mercury, you'll even see the sun rise and then set again and then again rise in a matter of few hours, few Mercury hours should I add. So you will find this kind of double sunrise or retrograde motion of the sun quite common in Mercury. Mercury is covered with craters. In fact, I'll show you a nice picture. This was a picture which was clicked by Messenger probe. You can see that this is a kind of smiley picture, you know. So it's a naturally formed smiley. It's the universe smiling at you. That look, even if the planet Mercury gets hit, keep smiling, something like that. I mean, it's covered with craters, but you can always find some humor in even that. By the way, you can see that surface is covered big craters and small craters of all kinds. There's nothing to this picture, just a fun picture, that's all. Our next planet away from the sun is Venus. Now, Venus has a nice look to it. Venus is supposed to be the goddess of beauty. Venus shines very brightly in the night sky, but you wouldn't want to go to Venus. The reason is that the Venus surface is completely covered with carbon dioxide, sulfur, and other inhospitable gases. In fact, the clouds on Venus are all made of sulfuric acid. So it's a very bad place to be actually. It's a very inhospitable place. And the moment you go there, you will be corroded because there's sulfuric acid everywhere. So it's not a nice place to be. It's like a twin, but not some place where you would like to be. The surface of Venus is covered with volcanoes, not surprising because of the sulfur content. And actually, there are some very nice geological formations on Venus which are called dome volcanoes. These are very wide domes. Instead of rising as a high hill, it spreads out horizontally and becomes a dome-shaped volcano. This is another picture of these dome-shaped volcanoes. No one knows what causes these dome-shaped volcanoes. No one knows what causes these very strange kind of uh, formations on Venus. Venus photographs are only possible using aerial probes. Landers are not easy because the surface is very, very bad. You can't find materials which would withstand that particular type of uh, corrosion. So it's not easy. And these are some things that even geologists are wondering about what makes Venus different from Earth. It's a nice thing to think about. The next planet, of course, we know is Earth. Then a nice photograph of Earth from NASA. NASA has an Earth observatory probe which he tries to click pictures of the Earth. Earth is a very nice place because there are lots of tiny things coming together to ensure that life is possible on Earth. If Earth was something like a 10 or 15% closer to the sun, life won't be possible because everything will get boiled off. If it is too much away, then things will get frozen. Carbon dioxide, for example, on Mars is frozen. So if that gets frozen, then there is no life cycle because carbon dioxide is essential to the life cycle. In addition, there is monsoon, there are winds, there is weather because of the correct tilt of the Earth's axis. If the Earth's axis was perfectly vertical and not tilted, we won't have that many seasons. The tilt enables us to have very different seasons, and the seasonal variations enable the rains to come from time to time, and that helps life to flourish on Earth. Looking at it from another perspective, Earth is also not a good place to do space exploration because only optical or visible light and radio waves are the only ones which can penetrate down to the surface of the Earth. If you want to study any other aspect of infrared, ultraviolet, X-ray, gamma ray, etc., microwave, you need to send some satellites into the sky which will be able to map those particular regions. So, from an astronomy perspective, you are better off launching a space probe rather than observing from Earth. But of course, from a life perspective, we would like to be on Earth. There is another interesting aspect that the Earth's surface, because it's a solid surface kept on a moving liquid surface, the inner and outer core of the Earth, inner core, we don't know, maybe it will be solid, but the mantle and the outer core are all liquid. So we are basically floating on that liquid, or our continents are floating on that liquid in the form of tectonic plates. And if you see the origin of the Earth, all the landmass was together in a single landmass called Pangaea, and later on it split into two, Laurasia and Gondwana land. And eventually that split into further the planet, the continents that we know today. In fact, if you notice, India was for a long time very close to Australia and Antarctica, and eventually it came and crashed against Asia. That is what caused the Himalayas, the Indo-Australian plate and the Eurasian plate colliding with each other, and the Himalayas keep growing every year because there is a lot of seismic activity also along the Himalayas because of the same reason that the two tectonic plates are colliding there. These poor guys who live in Japan have the worst time because they are at the intersection of three different tectonic plates. The small string of islands called Japan has to bear the brunt of the Earth's earthquakes. This is a political map just for fun. If Pangaea was divided into the countries it was currently, then Antarctica is close to India and Australia. Tibet is also near Antarctica, but China is near Russia at the top. So we all began at very different places and then somehow gradually made our way to where we are today. While talking about the Earth, it's necessary to talk about the moon as well. And if we talk about Earth's moon, we know there is a rabbit in the moon. That's the rabbit for you. But this is the near side of the moon, which you can always see. If we ever go to the other side, which you can do using a lunar probe, you will see that the opposite side of the moon is completely covered with craters. The side facing the Earth is never having much of craters. The reason for this is that the outer side of the moon, like Mercury acts as a shield for the sun, our moon acts as a shield for the Earth. So many asteroids or other space debris which were coming towards the Earth get attracted towards the Earth, but moon is in the way. And moon's one face, the rabbit face, keeps pointing towards the Earth. The other one is pointing away from the Earth, and that gets all the meteorite, marks. Coming to the next planet, Mars. Mars is again a very interesting geological planet. There are a lot of interesting features. There are polar ice caps which are consisting of uh, carbon dioxide. These are again seasonal. So there are seasons on Mars where the polar ice caps melt off, then they reform again and so on. There are canals on Mars which show that there was flowing liquid once. Maybe that was liquid water, maybe something else. We are not very sure. This picture shows a very vast volcano which is there on Mars. Since I am from Mumbai, Maharashtra, I just took a map of Maharashtra and superposed it. But you can equally take a map of maybe Telangana or Andhra Pradesh or Karnataka, and that will cover more or less like similar order of magnitude area. So this entire volcano is bigger than a major state of India in size. That I just wanted to point this out. It's also the tallest mountain in the entire solar system. This is called Olympus Mons. This is on Mars. So Mars has some very interesting geological features as well. Mars has two moons, which are called Phobos and Deimos. Mars is the god of war in Greek mythology. Phobos and Deimos means fear and terror. They are the size. Otherwise, they remain irregular shaped like this one. Meet, am I okay with the?
Yes, sir. There was some disturbance, but now it is okay.
All right, all right. Beyond Mars, you have the asteroid belt. Asteroid belt consists of asteroids, which are tiny rocks, And the asteroid belt basically consists of the last solid bits you will find more or less away from the sun. After that, you get the gas planets like Jupiter, etc. Jupiter is the largest planet in the solar system. It's the first gas giant planet. So these are gas planets which form beyond the solid region, which terminates with the asteroid belt. This is an actually a Voyager 1 probe which was launched towards Jupiter, which tried to go towards Jupiter, and the video ends when the probe got crushed because of Jupiter's gravity. But you can see that Jupiter has a very turbulent surface, lots of things going on, and these are all fluid or gas in nature. So these gases are all going around all the time. Okay, it's a very violent place to be. Jupiter is like a mini solar system. There are so many moons going around Jupiter. Jupiter doesn't have a fixed number of moons. It has hundreds, 100 moons or so, more or less. Sometimes some random piece of rock gets captured by Jupiter and starts orbiting around Jupiter. Then at another stage, it will get released and so on. These kind of things happen often with Jupiter. We are still taking count of the moons and we keep discovering new ones. Even you can do that with your backyard telescope and so on. The primary moons of Jupiter, called the Galilean moons, because Galileo could observe this with his tiny telescope in the 1600s, are these four: Io, Europa, Ganymede, and Callisto. They are all similar in size. With a decent telescope, you can actually see all four of them, like this picture which is shown here. And these are again geologically very different. Europa is completely covered with ice. Io is completely full of volcanic activity. This is the closest moon to Jupiter, and therefore Jupiter's gravity keeps creating more and more volcanic activity on Io. It's not a good place to be. Ganymede is again different. Callisto is again, it is covered with lot of debris marks from uh, projectiles which are coming towards Jupiter. So you have these principal moons of Jupiter, and then you have several other moons. It's like a mini solar system all of its own. It's not a real solar system because Jupiter doesn't have enough mass to become a star itself. You need a certain amount of mass to initiate that hydrogen helium fusion reaction, and then you have a star. Jupiter failed that test, not big enough. Maybe it was a little bigger, we would live in a twin sun solar system kind of thing. This is an interesting picture. The pink is the asteroid belt, and the green are some asteroids which get somehow trapped in the gravity between Sun and Jupiter. These are called the Lagrangian points of Jupiter's orbit, L4 and L5 points. And these green are asteroids from the asteroid belt which got somehow captured within the orbit of Jupiter, moving either ahead of Jupiter or behind. One group is called Greek asteroids and the other is called Trojan asteroid, because Greek and Trojan are enemies and they're Greek, no other reason, I suppose. And you can see some of these suddenly escaping and coming towards Jupiter and becoming moons of Jupiter temporarily and then going back and stuff. You can see that happening in this video. This is an actual simulation with real objects. It's a actual plot of the movements of different real objects. It's not a simulation. It's a real position of real objects. The next planet in the solar system is Saturn. Saturn, as you know, has rings. I like to call Saturn Lord of the Rings because so many rings. It's a very beautiful object to look at when you look at it through a telescope. And there are many names for the rings based on who discovered them. There are some gaps in these rings based on who discovered the gaps. All these are fine. This is a picture, real picture of Saturn, by the way, such that this was taken by the Cassini spacecraft, and the sun is on the other side. So sun is shining from behind Saturn, and so you can see actually like an eclipse like formation here. Sun is behind Saturn, so it's like illuminating Saturn from the back, and these are photographs taken that way by Cassini explorer. And there are so many rings, and apart from the rings there are moons also. The named ones here, Mimas, Enceladus, Tethys, Dioneira, these are moons of Saturn. Titan, Hyperion, Iapetus, and Phoebe are even further away, and a few couple of the what you say moons are here: Atlas, Prometheus, Pandora. These are moons. Janus and Epimetheus, these are all here. So there are lots of moons interspersed among these rings of Saturn. And if you count all the moons, these are the inner moons, which the named ones which we saw here. There are several outer moons which are rotating all around Saturn in this kind of crazy manner. So the rings are basically formed by some moons which came too close to Saturn, and Saturn's gravity basically broke them up into tiny pieces. It's like a bundi laddu which is taken too fast. It will just break up. That's what happened to those moons which came too close to Saturn. If you want to come that close, you need to have a certain mass. If you are smaller than that, you will get powder. That's what happens near Saturn. Saturn also has a strange hexagonal pattern at the poles.
Sir, again, there's some network issue from your side. Mm.
Hello.
Yeah, now clearly audible. Uh, Again, it has stopped. Can you check?
Hello, Meet.
Yes, sir. Yes, sir, I can hear you. But your video is lagging. So I can. Okay, so sir is having some network issue.
Hello.
Yes, sir, now I can hear you.
Okay. So I am very sorry. I am in a place not at my home or office. I am actually visiting Delhi for some
Yeah, no problem.
experimental work. And the network here, unfortunately, I cannot vouch for it. So that is happening. I hope we can continue from
Yes,
where.
sir. Yes, sir. Please.
Let's try. All right. So as I said, you can mathematically actually predict that this will happen with Saturn's poles. All right. So I am trying to do this now. Uranus. The next planet is Uranus. Uranus is a very weird planet because have a look at this picture. You see, all these other planets have their axis of rotation more or less tilted at a almost zero or a small angle from the sun. But Uranus has an axis pointing right along the sun, which means that one side of Uranus will always have day and the other side will always have night. So that's just weird to start with. Another weird thing is Uranus also has a magnetic field. That magnetic field is fine, magnetic field is pointing kind of in this direction as shown by the red arrow. So the magnetic field offers a protection shield in this direction, which more or less shields the planet most of the time from sun's magnetic field. So this is some just interesting fact about Uranus. Neptune is the opposite. Neptune has a magnetic field which is weird and rotation axis which is fine, which is even worse because it allows the sun solar wind to harm the planet badly, but nothing happens. This is a photograph of Uranus taken by James Webb Space Telescope, the new one. This is a close-up of that. But a much nicer and clearer picture is taken by Voyager 2 in 1987 or so. What this tells us is that why to spend so much money to send space probes. The reason is the space probes can return you photographs which you can't do sitting in your backyard. James Webb is right here orbiting around Earth. It can't give you as good images as you can get if you send a much worse camera much closer to Uranus. That is what is happening here. This is a 1987 camera, Voyager 2, versus a 2024 camera, James Webb. And you can see the difference. The 1987 one is clearer. The reason is you need to get close to these objects to study them. You can't study them sitting right here on Earth. Just a point I wanted to make. Uranus also has rings, same reason. Some object came too close, got powdered, and that powder kept orbiting around Uranus. The next planet is Neptune. Is kind of last stop as far as our major planets is concerned. Again, my same point. Voyager photograph taken in 1989, Hubble Space Telescope photograph taken in 2021. See the difference. You need to get a camera close to the object. So this is a big case for why we need space exploration and why it's so important to have programs like NASA, ISRO going on. All right. This is a X-ray picture of, or I think UV picture of Neptune taken by James Webb, and you can see Neptune also has a few rings. So those rings are again for the same reason. Neptune has this weird magnetic field, which sometimes half the time it allows the solar wind to penetrate inside, and therefore it's not always protected from the solar wind. Doesn't matter because it's a gas planet anyway, but just an interesting fact. If you look at Neptune from close up, it's blue in color because it consists almost entirely of methane. It also has a lot of strange activity like Jupiter and Saturn, that there are these gas whirlpools which are going around all over the planet. These clouds are actually methane clouds which are there on Neptune. Okay, this concludes our overall section on planets, which already we have seen there is a wide range of variety. You have volcanic, non-volcanic, ice covered, methane covered, CO2 is there, so many things. Next stop in our journey is to look at dwarf planets. One of the first known dwarf planets, of course,
Then again, I guess there is some network issue. So, students, sir is facing some network issue. He will join in a minute. Yeah, so sir has reconnected again.
yeah, I think this keeps going off. My internet connection is unstable. Am I audible, Meet? Is it okay?
Yes, sir. Yes, sir. Clearly
Yeah,
audible.
I'm very sorry about this.
No
I
problem, sir.
feel bad. So many people are watching and this happens. Can't help it. Pluto. As I said, Pluto and Charon are a binary system which revolve around each other. Charon is only somewhat smaller than Pluto. You don't call them two separate planets. It's the same dual planet system, double planet system. Pluto has some other moons other than Charon, and it's located in the Kuiper belt. The reason Pluto was demoted from planet status is because there are much other debris in Pluto's orbit. Only when Pluto manages to gather all that debris and form into a bigger planet, then we'll call it a planet. Right now, it has not cleared its orbit. That's what they say. That's the term used. That there is a lot of other debris in its orbit, then it's not called a planet. It's still a dwarf planet. All other dwarf planets have the same reason to be called dwarf planets. The next dwarf planet we'll look at is Ceres. Ceres is actually somewhere in the asteroid belt. It's located in the asteroid belt. And this is a close-up photograph of Ceres actually. And it's a large asteroid which is large enough to obtain a spherical shape. And so it's worthwhile to call it a dwarf planet. It's the biggest object in the asteroid belt as such. And it's called a dwarf planet. The next dwarf planet we'll talk about is a dwarf planet called Eris. Eris is a very, very far away planet. The discovery of Eris, I'll show you how these planets are discovered. Basically, you can see this photograph. This is a series of 3 photographs which were taken, and if you observe very closely, there is a point which is moving. So this is a photograph of the entire sky. You can see many stars, but you can see only one star which is moving from one point to other. If you have not spotted it, here it is. You can see this guy. He is moving while all the others are remaining stationary. One guy is moving. That moving guy is a planet. So you take a photograph during the night, take 5 or 6 photographs pointing at exactly the same stars. If one of the stars appear to be moving, then very likely that is not a star, that is actually a planet. And this is how you can discover new planets. These kind of things amateur astronomers can easily discover in their own backyard with a decent camera and a decent telescope. So this is that Eris planet. This is the way it was discovered in Palomar Observatory in 2003. And Aries is, of course, it has one moon, but we don't know much else. It's well beyond Pluto also. It's very, very far away. It's almost twice the distance of Pluto from the sun. The next planet, which is very interesting, which we are going to talk about, dwarf planet, is a planet called Haumea. It is located again in the Kuiper belt, which is basically, it's in the same orbit or similar orbit to Pluto, around the same region.
Okay. So I guess sir has disconnected. So we will wait for sir because he's facing some issue. He's not at his home or in the office. He is out in the outstation. So that's why.
Hi.
Yes, sir.
I'm so sorry about this. I really feel so bad.
No problem, sir. We can understand you are outside. You are not at.
Yeah. Is this okay? Now can we continue?
Yeah, yes, sir. Yes, sir.
So
We can continue. Students are waiting and they are also interested to know more.
yes, yes, yes. So I was talking about this planet called Haumea and how it is a, Jacobian ellipsoid instead of being a ordinary, object. So it actually has uh, this strange shape, but this strange shape is evidently allowed by the laws of gravity. Object can take this shape instead of a perfectly round shape, and so that's very interesting. Uh, in addition, it actually has a ring of. It has a few rings which are not visible, but it's very strange that a small object could disintegrate other objects and actually do that. These are a couple of moons of Haumea which are seen in this photograph. This is an actual photograph taken by Hubble Space Telescope. You can't see much because it's so far away. The best thing is if there is a probe which goes out, you can see it better. The next planet which we look at is another dwarf planet called Makemake, and it's another Kuiper belt object. So you can see Pluto is far from being a planet because there are three Kuiper belt objects which are talked about. One is Pluto, one is Haumea, and one is Makemake. They are all around the same place. Not at the same place, distributed around that orbit. Makemake also has a moon, which you can see in this image, Hubble Space Telescope image. This is a summary slide showing all these nice dwarf planets and where are they and how are they going to go. There are a couple of others which I didn't talk about, because they are not even officially called dwarf planets yet. International Astronomical Union has to take a call on those. Gong Gong, Sedna, Orcus, Puar, and so on. So these are around 9 dwarf planets in this picture. 5 I showed you slides on, 4 more are there. And they are all very, very small and they are far from being planet status. And this just shows how they are moving around the sun just for fun. This is just a animated thing, and the orbital period is also shown if you are interested. Kind of that's just a overall picture of these objects. Yeah. If I have more time, I would like to tell you about a few more nice things about the solar system. There are a few wandering objects. One of these wandering objects are asteroids, which we already talked a little bit about. Asteroids are basically rocks which are between the orbits of Mars and Jupiter in the solar system. And these rocks basically have their own region, and probably eventually, given enough time, all these rocks will coalesce into one planet, and what that will do to the dynamics of the solar system is a very strange and long story, if it ever happens. So basically the asteroid belt is one failed planet which got disintegrated at a certain stage, and then after that you can't bring them all together. they're just horribly kind of distributed all around the place. Okay, this shows it much more dense than it actually is. It's not that bad. The other interesting objects which you have are comets. Now, comets are different from asteroids. Okay, comets are not just rock, but rock on which a lot of gas has condensed. So basically, these are like ice balls, balls of ice. And these balls of ice, when they come close to the sun, what happens is the sun heats up this ice, and then this ice starts escaping in the form of gas. So the escaping gas actually is always it's escaping in such a way that when the comet is moving, it is escaping opposite to the comet's motion. Apart from that, the solar wind also heats up the comet, and the solar wind direction is shown as a straight line. So you can see every comet has two tails, one yellow tail and blue tail, as shown in the picture. Yellow tail is because of the gas, and the blue tail is because of the solar wind carrying away dust from the particles. So you have got a dust tail and a gas tail. So every comet actually has two tails. And there are many classes of comets originating from near the asteroid belt, then comets which are originating closer to the Kuiper belt, and comets which are coming from very far away. All of these have very different dynamics, very different orientations, and very different ways in which they evolve, and they can give you a lot of information about the outer reaches of the solar system, away from the solar system. Another interesting thing which happens a lot is meteor showers. Meteor showers are a very special thing because whenever a comet is going past the sun, here I have shown a comet called Swift Turtle Comet. When it is going past the sun, what happens is it leaves a lot of dust along its path. And whenever Earth's orbit crosses that trail of dust left by the comet, during those particular dates, you will suddenly see all that dust lighting up in the sky in the form of meteorites, small meteors. So these are called meteor showers. They happen at very specific nights of the month, of the year, rather, very specific days of the year. So you can actually go on those days to a quiet place where the sky is not polluted, away from a city, and you will be guaranteed to see meteor showers if you are watching carefully. So this happens on specific dates because those are the dates on which Earth's orbit actually crosses the orbit of those particular comets. So this is a very interesting phenomena. How do we know where the comets are moving through? We know because apart from seeing the comet, if it's far away, we still know the dust trail which it has left along its path. And when Earth passes through that dust trail, you get meteor showers. It's a very interesting thing. Just to conclude, this is what we have in the solar system. You have these 8 planets, you have all those dwarf planets, and then you have got all these moons to these big planets and small planets. All these objects are part of the solar system. The distance from the Earth to the Sun is called 1 astronomical unit. This is what is used for measuring the distance. All right. And if you look at the objects like Pluto, etc., then you will find that that is at several tens of astronomical units, up to 100 astronomical units around. And that is not where we stop. You see, asteroid belt is at around 3 astronomical unit as shown here. This is the asteroid belt. Then if you look at the outer Kuiper belt objects like Pluto, Kuiper belt is at around 40 astronomical unit to around 70 astronomical unit, somewhere that range. And if you look at a even larger scale outside the Kuiper belt, you have got a ring of dust and gas, all of which are gravitationally attracted by the sun. So all these are held together by the sun. And this Oort cloud, this large ball of dust and gas, which is far away from the sun, extends to something like 5,000 to 100,000 astronomical unit. Very far away. 5,000 times the distance from sun to earth. Now from sun to earth, it takes light 8 minutes to come from sun to earth. So to go for 5,000 astronomical unit, it will take almost a day kind of thing. So that is the kind of region you are looking at. If you shine light from one end of the Oort cloud, it will take days to reach the other end of the Oort cloud. It's that large a structure. All of this is gravitationally held together by the sun. So again, this is another picture showing the same thing. You have got the sun, you have got the inner planets, you have got asteroid belt, you have got outer planets, then you have got Kuiper belt, and then outside the Kuiper belt, you have got the Oort. So as my friends Calvin and Hobbes, as they say, it's a magical world, and the best we can do is go and explore this world. And so that is why we keep sending out space probes. And just like that, what we should all do, I feel, is we should all keep exploring. It brings me to a stop of what I was supposed to give you as a lecture. I was also asked to talk about Meet if I have time.
Yes, sir. Yes. You can take 5 minutes, sir.
I was asked to talk about what you should do when you are in school so that when you graduate or when you complete your education, you can launch yourself into the field of astronomy and astrophysics. So that's a very nice question. I feel that the best you can do is concentrate very hard on all your subjects. Okay? Because you see, normally people will tell you concentrate on mathematics and science. I don't subscribe to that philosophy. I feel you should concentrate on all your subjects because you never know. You need all kinds of people. You need engineers to design the space probes. You need aeronautical engineers and mechanical engineers. You need chemical engineers to design the fuel. You need a physicist to calculate the trajectories of how these things will go. You need chemists who will design the payloads which will be taken on these places so that we can do a quick analysis of what we find over there. You need biologists because you need to know if it's a manned flight, then how you are going to go about it. You need doctors, you need medical personnel. Okay, you need good communicators, good science communicators. So if someone has a degree in, let us say, engineering or even science and has a master's degree in mass media, we need that kind of people also who will understand technically what is going on and then communicate that in a language which is useful for the general public. So there is no one stream which will take you there, but there are opportunities. Whatever you do, there is always an opportunity to go into the field of space exploration. If you are more interested in astrophysics, that is trying to understand how these things evolve, and the allied fields of astrochemistry, astrobiology, then you would be better off doing a master's degree with physics or chemistry background, and then you do a PhD in those specialized fields which we are talking about, so that helps you to get into those particular fields. Astrobiology is a major field coming up these days. Astrochemistry has been around for quite some time. Astrophysics is now a traditional discipline. So all kinds of interests which you have, don't allow anything which is not of your interest to attract. Go for the subject of your interest, and there are always ways to link it back to the field of astronomy. Okay, astronomy itself, you don't need to do a master's degree or something. You do a bachelor's degree and you need lots of hands-on experience and handling telescopes, etc., and you can be an astronomer any day of your life. Thank you so much.
Okay. So thank you so much, sir, for such a wonderful talk, which covered information about the solar system in very great detail. I personally like the visuals in the presentation, also the way you covered all the things in the solar system, despite having time constraints and an unstable network. But I'm sure students have really enjoyed it. Now, with your permission, I would like to take a few questions from the chat box.
Sure.
Yeah. So, sir, one question that we have got, it is from Gurjit. Is asking, sir, is there diamond rain on Uranus? And this I have got from many students.
A diamond ring.
Yes.
Is this from my slides or is this a general question?
It's in general question. Many have seen the news that there is a diamond rain on Uranus and other planets. So, is there such thing happen?
I mean, if you have carbon compressed under sufficiently high pressure, you will get diamond. It is not something you can do anything about. As I said, it is hard enough work to get a small space probe with a small camera over there. Definitely, we are not at the position where we are going to exploit that. But in the long term future, maybe something may come about. Uh, it's also not 100% sure that when you go there, what you will find is a diamond ring. That's just what it appears from all the spectroscopy which people have done. So only time will tell what's the reality.
Okay. And another question that we have, it's from Samiksha Pandey. She is asking, why does Saturn has polar hexagon?
No one knows the answer to this question. The gas there just evolves that way. Uh, some people, as I said, in Harvard University, they tried to model this gas using some known equations of fluid dynamics, and they were able to reproduce that motion. I have not really gone into details of that study, but basically, this has to do with the conditions just below the surface, how much heat is being generated, or how not generated, rather how much heat is there trapped in the inner core, etc., those regions of Saturn, and how much of that is percolating up to the top. And under a certain conditions of temperature and the speed of rotation, those vortices form in that way such that it gets a hexagonal structure. The hexagon is real. The hexagon can be modeled mathematically based on certain initial conditions. That much I can tell you. Why it is there? It's just there. That is my answer to almost everything.
Okay.
In fact, Richard Feynman, the famous physicist, always used to say, if you ask me how a certain thing is working, I can explain to you based on these are my assumptions. And when I take these assumptions, put them into the correct equations, I get this result. It is working. If you ask me why it is working that way, the only answer is God made it that way. There is no real answer to the question of why. It's an interesting question to keep asking why, because when you keep asking why, you get answers to all kind of other questions. So that's how the process of science works. Nice question.
Yeah. And we have one more question from Chandru. He is asking that why this Venus is so bright, like why it is having this reflection of light coming from it.
Venus is closer to Earth, and it is large enough in size so that you can see it quite prominently. I mean, why is Mars less prominent than Venus? I think it's just a matter of size, and Mars is slightly more far away from Earth. And the other thing is Venus is, I mean, it keeps close to the sun. So Venus is normally seen very close to sunrise or very soon after sunset. And just after it becomes dark, Venus appears very bright. Right now, you can see Venus right next to the moon. I mean, if you go out tonight, I don't know if today is new moon or there is still little bit of it left. Yesterday, it was a crescent moon and Venus, they were on the same level in the sky. It was very nice.
Yes.
It's bright just because it's closer is my answer.
Okay. 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 Sir, once again, thank you very much for your time and for this wonderful presentation.
My
And
pleasure. Thank you so much for inviting me. I hope all the kids like the talk.
yes,
And
sir.
all the best to all you guys who want to do astronomy, astrophysics, or any allied astro related field in the future. All the best to you in your endeavors.
Yeah. Thank you so much, sir. And a huge thank you to the audience of such wonderful students who made this webinar series very interesting and engaging. Thanks a lot to all of you. And